Welcome back to the deep dive. So, if you've been following along, we've spent the last couple of dives really building out the administrative scaffolding of GitLab. We talked about groups, that big organizational umbrella, and then subgroups, which, let you mirror your corporate structure.
Exactly. We've been talking all about the organization around the work, setting up the rules of the road for whole departments.
High-level governance.
Right. But today, we finally get to the core, the final destination for all that effort, the project.
Yeah.
This is really where the work happens.
Okay, so we've built the office building, we've laid out the floor plans, and now we're actually walking up to the desk where the work gets done. For you, the listener, how should you visualize this project, especially compared to the group?
Well, the best analogy is still that office building. The group is the building. It sets the big security policies, who gets in the front door.
Right.
The project, though, that's your actual desk. It's that highly organized space where you sit down and all your files, your tools, your notes, it's all right there.
All in one place.
All in one place. By definition, the project is the single source of truth for a specific piece of software, a service, a product, whatever it may be.
And that idea, single source of truth, that's so critical. It means it's more than just a folder with code in it.
Oh, much more.
So our mission today is to figure out what makes this container a whole DevSecOps ecosystem. And I think really importantly, we need to clarify how it handles access control and visibility, because it seems like this is where things can override that inheritance we talked about with groups.
Absolutely. Understanding the project level is the final essential piece. It's where that high-level policy meets day-to-day execution.
Okay, let's unpack this then. We know the project has the source code, but that's table stakes. If the repository is just the code, what else is actually bundled into that project container? What makes it an entire ecosystem?
The magic word is integration. It's designed from the ground up to be an all-in-one DevSecOps toolchain.
So everything you need from what, an idea to deployment?
Everything. From the issue to the code review to testing, security scanning, all the way to deployment. It's all baked into that single project. One name, one URL.
That sounds like a huge reduction in cognitive load. I mean, just not having to switch between 10 different apps.
It's a massive hidden cost for most companies. So we can break it down into 6 core components all bundled together.
Okay, let's do it.
First, the foundation is the repository. That's your Git code, the full history, branches, tags. Simple enough.
Right, the code itself. Check.
Second, you have issue tracking, and this is your project management layer. Bugs, user stories, feature requests, tasks. This is where the work is defined.
So the plan.
The plan. And third, maybe the heart of all the collaboration, are the merge requests. This is the critical mechanism for proposing a change, kicking off automated tests, doing that peer code review.
And then finally getting the code merged in.
Exactly. So we have the code, the plan, and the collaboration.
Okay, so what's driving the automation side of things?
That would be component number 4. CI/CD pipelines. This is the engine of the whole operation. The build, test, deploy scripts. Right. But what's really important to realize here is the scope, the pipeline definitions, the environment variables, the secrets. They're all scoped to this project.
Ah, okay. So even if the parent group says all production deployments go to the EU cloud, the project itself dictates how its specific code gets there.
Precisely. Right down to the specific API key it uses. It gives the project team autonomy over their process while still, operating inside the group's guardrails.
That distinction is huge for auditing.
It is. Then for the final 2 pieces, we have knowledge management. Number 5 is wikis. This is for your long-form documentation, onboarding guides, API specs, that kind of thing.
Okay.
And 6th, we have snippets, which is a super useful feature for small reusable pieces of code. Config files, little scripts, things that don't really belong in the main repo, but you need to manage them somewhere.
The power of that is so clear. When you onboard a new developer, you don't give them 5 links, you give them 1. And that one URL is their code, their roadmap, their deployment engine, and their knowledge base.
That's it. It just cuts down on that tool switching tax that really slows teams down.
All right, now let's pivot to governance, specifically access. We've talked a lot about how groups handle inheritance. If I'm a maintainer in a group, I'm a maintainer everywhere underneath it.
Yeah.
So what's the project-specific
Unique job here. How does it refine that?
And that is the essential distinction. It's where a lot of people get tripped up. Groups handle the broad strokes, the inheritance. Projects, on the other hand,
Handle 2 key things: direct access and feature visibility.
surgical precision?
That's the perfect way to put it. This is where you get really granular with permissions.
Okay, so So give us a real-world scenario. When is relying only on that group inheritance a bad idea?
Think about a contractor, a security consultant. You have a big group, Acme Internal Tools, with 20 projects in it. Project A is a critical billing system. The others are just general utilities.
Right.
You hire a consultant for 3 weeks, and their contract says they only touch Project A. You absolutely do not want them even seeing the other 19 projects.
And if I add them to the parent group, even with the lowest role, they can see everything.
Correct. So the clean solution is to bypass the group entirely. You invite that consultant directly into Project A, you assign them a role, say developer, and their access is strictly scoped just to that one project.
And when the contract's up, you remove them from that one project and they're gone from the entire organization.
Exactly. Clean, simple to audit.
That makes perfect sense for externals. But what about an internal person? What happens if someone inherits a low role, like reporter, from the group, but you need them to have a high role in one specific project?
Now we get to the most critical rule for permissions. It's called the highest role rule.
The principle is actually pretty straightforward. A user always gets the permissions of their highest assigned role. The system just looks at all their roles, inherited and direct, and gives them the most powerful one.
So it resolves conflicts by defaulting to more power.
Exactly. Let's use an example. Jane is a reporter in the parent group. That gives her read-only access across all the projects.
Okay, she can see things, leave comments.
Right. But Jane is the lead on Project Beta. So you go into Project Beta settings, and you invite her directly with the
Maintainer role.
Ah.
So now her effective role inside Project Beta is maintainer. She can manage members, merge it to protected branches, configure CI/CD.
all the things the maintainer can do.
But only in Project Beta.
Only in Project Beta. Everywhere else, she's still just a reporter. It's a strategic override. The direct project assignment trumps the lesser inherited role, but only within that project's walls. It's targeted authority.
That has huge governance implications. It means an auditor can ask who can merge to production for Project Beta. And I only need to check two places. The direct members of that project, and anyone who inherits maintainer or owner from the parent group.
It makes the compliance check so much simpler. And what's interesting is, this isn't the only major control point at the project level. The other one is visibility.
Right, which affects everyone, not just members. Let's quickly review the three visibility levels again. I feel like this is always on the exam.
It is. So first you have private. This is the default. It's the safest. Only members of the project or a parent group can see it.
Got it.
Then you have internal.
Okay, and internal means any logged in user
On my specific GitLab instance can see everything.
Exactly. They can see it, they can clone it. It's for, proprietary tools that everyone in the company should have access to, but that should never, ever leak outside the company.
And finally, public. The open source setting. Anyone on the internet.
Anyone.
Yeah.
They don't even need an account. Which brings us to probably the biggest, most critical rule about visibility inheritance.
Okay.
A project can never have a higher visibility than its parent group.
The container limits what's inside it.
Yeah.
That makes sense. So let's create a scenario. My main group, Finance Tools, is set to internal because obviously it's sensitive.
Right.
And a developer on my team builds a cool little utility inside that group, and they want to share it with the world. So they go to their project settings and try to set it to public.
The system will just say no. It rejects the change. Because that parent container, the Finance Tools group, is set to internal, the absolute maximum visibility any project inside it can ever have is also internal.
It's a hard ceiling.
It's a foundational security guardrail. It prevents a developer with the best intentions from accidentally exposing sensitive IP just because they forgot what group they were in.
So for you listening, if you want to launch an open source project, you have to make sure its parent group and its parent's parent group all the way up are also public.
That's the rule. The group admin holds the ultimate veto on external visibility.
Okay, so that covers roles and visibility, the main governance controls. Let's talk about the final piece you mentioned, the project level customization. I can imagine a lot of teams don't use every single one of those 6 features we talked about.
Oh, absolutely. And that's another powerful control you only get at the project level, feature toggles.
So I can just turn things off?
Yep. Every project has a settings page, and you can literally just flip a switch to turn off issues or wikis or CI/CD pipelines.
Why is that strategically important beyond just, tidying up the sidebar?
Well, a few reasons. First, just what you said, UI simplification. It reduces cognitive load. If your team uses Jira for everything, just turn off GitLab issues. No confusion.
Makes sense.
Second, it can reduce your audit surface area. If a compliance rule says no documentation outside of Confluence, you can just disable the wiki on all your projects. It makes proving compliance much easier.
Can you give us a really simple workflow example?
Sure. Imagine a team that just maintains a simple, static documentation website. It's just markdown files. They don't track bugs. They don't have complex features.
So they don't need issues or merge requests, really.
Exactly. So they can go into the project settings and just turn off issue tracking and merge requests. Now, when the developer on that team looks at the project, they only see the repository and the wiki buttons.
That's it. It focuses the experience.
It focuses the experience entirely on what they need to do. It's about customizing
That full DevSecOps experience to match the specific needs of that one code base.
That makes perfect sense. Okay, so let's try to synthesize all of this. Projects are the core working
Ecosystem. They bundle everything, code, planning, automation, device into one central hub. They handle that final granular point of access control with direct assignments, and they follow that highest rule. They are strictly bound by their parent group's visibility. They can't be more public than their container. And finally, you can customize them by toggling features on and off to streamline the workflow.
That's a perfect summary. And when you understand that tight relationship from the group down through subgroups, all the way to that single project, the whole GitLab organizational model just clicks into place.
It really does. It gives you the full blueprint for policy versus execution.
Indeed. And, if you think about this flexibility, it raises a kind of interesting question for you to think about. Considering how granular these controls are, the feature toggles, the role overrides, the visibility
Constraints. How might tailoring the toolchain and the visibility for every single repository change how big organizations approach compliance? Shifting it from just a top-down mandate
to a configuration choice you make right at the moment of creation.
Something to think about as you start setting up your own project structures. Thanks for diving in with us on this.
Anytime. See you next time.